Hello, good morning, good afternoon, good evening. Welcome everybody to today's tech session brought to you by Empire Engineering. Hello, Carl, a regular visitor to our sessions. Good to see you again. My name's Stu Pringle. I'm your host for today's session. This is season 2, episode 2 of the tech sessions, and today's topic is all about fabrication limitations in offshore wind. Welcome you all to join the discussion. I'll introduce the panel in just a moment. But before I do, a word about our hosts. Empire Engineering are a team of deep thinkers. Empire Engineering is an engineering consultancy in the offshore wind industry that offers advice, insight, and technical know-how. I'd also like to thank our sponsors of this series, which are ITH Bolting and SIF. So thank you to them both, without whom this whole series wouldn't have been possible. Now then, on to today's session. You'll see there's a chat screen down the right-hand side, everyone. Please do say hello. I can see a few of you. Freddie, Carl, Jason have all been saying hello already. You can also ask a question at the bottom. So if you hit the Ask a Question button, you can ask our panel a question as we go. And we'll also have a poll for you all for a bit of participation in just a moment's time. Okay, that's the housekeeping out of the way. Let's get on to today's topic, fabrication limitations in offshore wind. I'd like now to introduce today's panel. So today I am joined by Michelle. Michelle, would you like to say hello?
Good morning, I'm Michelle. I work for SIF.
Good
Very
morning.
happy to be joining this meeting.
Lovely to have you with us. Thank you very much. And also today I have Sergio.
Hello, good morning everyone. My name is Sergio Tolaguirre. I work for ISEA Wind Group, and we have production facilities in Bilbao as well as in Argentina and Aranda de Duero, inland Spain, for towers and also for foundations in Bilbao.
Lovely. Great to have you along. Thanks, Sergio. And we have Phil.
Morning, everyone. Phil Coombs here from Ramble, working on foundation design. And yeah, very happy to be part of this.
Excellent. Thanks, Phil. And last but not least, we have Nick from Empire. Nick, hello.
Good morning, just yeah. As you say, I'm Nick Howard. I'm a partner and principal engineer at Empire Engineering.
Excellent. Right, we've got the hellos and introductions out of the way. So without further ado, let's get into the topic itself. Why don't we start with a poll? We've got a big audience here today. So let's ask them a question. Everyone, you'll have just seen the poll at the bottom of the screen and a red 1 appear on your screen. If you click on that now, we would like to ask you, by 2030, do you think a 15-meter diameter monotile will be fabricated? Is this an absolute given? Is it probably yes? Is it, I'm not sure? Sorry, my friend, I don't think so. Or not a chance. Come on, everyone, what do you think? The votes are flying in, and it's looking pretty positive at the moment. I think this will keep the designers happy. So we've got a race between absolutely yes and probably yes. And no, not one single person has voted not a chance. So we probably had 60, 70, maybe heading towards 100 votes so far coming in. So it looks like probably yes is the answer. So I think that will be an interesting context for today's discussion. Okay, I think it's about time you heard enough of me and started hearing from the panel. So I'd like to start with a question. A question I'm going to ask for the two fabricators in the room. As we continue making bigger monopiles, which part do you see as the weak link? Is it the plate? Is it the welding? Is it somewhere else? Come on, tell me. What do you think? Michelle, I'll start with you.
There's actually no limitation into scaling up the monopile if you want to see it from an engineering perspective. From a fabrication perspective, also, I can't see a reason. We've been scaling up the last 20 years, and indeed, every step gives you new challenges. That's why we do it incremental in steps of 1 meter, and we don't make jumps, very big jumps in scaling up in order to stay predictable. But actually, I think at the end of the day, the limitation will be much more an economical one, because I think at a certain moment of time, the amount of steel required is so much that there's other foundations being more competitive and more economical.
Very good.
Michel,
Thanks, Michel. That's good opening statements. Sergio, what would you say to this question?
Well, I agree with Michel's position, and I would add that we have to see the limitation of the monopile foundation from three angles. The first one being the capability to design and manufacture larger monopiles, and that's thing that I think that can be solved. Then we have the capacity challenge, and there the question is, okay, we are able to manufacture a 15-meter diameter monopile, but are we able to manufacture 2 per week that the wind farm will require? That's of course a challenge. And then the third dimension for this challenge is the efficiency. So are we capable of doing it? Are we capable of doing it with the required pace? And are we capable of doing it with the required cost? So there will be challenges. The monopile will scale up for sure. And we just have to go and solve the challenge step by step, as Michel pointed out.
Interesting. Okay, so we've heard from two fabricators there. I'd be interested to get the designer's view on this question. Phil, I might go to you first.
Yeah, so again, I think we're all pretty well in agreement on that one. I think the limitations for us as designers are even lower than for the fabricators. I mean, in terms of the way that we analyze a monopile, there's no reason why you can't keep increasing the diameter, keep increasing the wall thickness. That doesn't mean that we work without constraints. Often the constraints in our design are actually coming from the current limitations of fabrication yards. That might be, can length limits or can weight limits. The good news hearing from Michel and Sergio is that they will continue to go up. So I don't really think that we are constrained in the same way, constrained in that way at all at the moment. I would agree completely about it becomes about economical questions of which foundation suits a certain project best. And there's lots of different factors for why a monopile or a jacket or a floater might be, the most appropriate one, site conditions, ground conditions. So theoretically, yeah, we can keep going up, but I don't think it'll keep being supersized monopiles forever.
Very good, very good. And Nick, any thoughts on this one? Just build what you design. Is that the short answer?
Guys, just make it. No, I wanted to. I think Michel, you said almost as your first response that there's no kind of real sort of technological limitation, and I was curious what the last time you scaled up in terms of diameter, what the kind of limitations you ran into or the problems you ran into, was it just upgrading machinery and tooling to handle the new diameters, or were there kind of processes or welding issues that you ran into?
I think there's always a range in which you can call it evolution, and you just scale up step by step, but you're actually doing the same process and executing the same sort of technologies that you've been executing in the step before. And every 4 or 5 years, you have to kind of take a step back, because what we've experienced with every meter of diameter that we enlarge, there's about 80% of the effects on the shop floor that we've predicted and modeled, but there's 20% of the unknown unknowns that appear, and that makes you wonder what is happening here and how can we solve it. And luckily, we have the experience in order to then adapt and have the flexibility to make it work. And basically, it's not only the fact that we're going up in diameter, but it's also that we're going up in the ratio D over T. And so the diameter versus wall thickness. So basically, what we're seeing over the years is the diameter is growing and the wall thickness is actually staying more or less the same, or actually diminishing a little bit. So every 5 years, you really have to take a break and to have to look at, is this still the best way to go, or do we do something completely different? And we are just at that point. So we are now going to go for a completely new step, to go and make the step from 9 to 11 to 15.
Interesting stuff. Okay, well, look, everyone's agreeing so far, and I don't like that. I want to try and get some debate going here, some differences of opinion. We've talked a lot about scaling up technologies. Does that mean we're just going to make everything else bigger as well, or are we simply going to scale up existing technologies as everything gets bigger, or take flanges for example? Is there a technical or commercial hard maximum that we can go no further? I might ask the designers first. Phil, what do you think?
Yeah, so in terms of bolt connections, I think people have talked about the hard limit for a while. I don't think we're quite there yet. I've worked on a couple of projects recently where we're using M80 bolts. There's talk of potentially M90 or maybe even M100 bolts being used. So I still think we have a bit more to squeeze out there. We will run into issues. Fatigue of the bolts is often a big one, or sometimes actually the ULS capacity of the flange itself can be limiting. It's not always clear cut one or the other. So I think we have scope to squeeze a little bit more, but then I do think these new technologies will become more prevalent. Things like the C1 connection show potentially quite a lot of promise. They haven't been deployed full scale yet, so it'll be interesting to see which developer on which project is willing to take the plunge for whatever reason and take that first step to do a new technology. Because some projects are suited to it. Other projects, sometimes have commercial constraints or very compressed schedules, and they're not suitable for those, big innovative leaps forward. So yeah, it'll be interesting to see which one is the first to do something completely new.
Do you think it's just an element of being a little bit brave?
Potentially. And yeah, it's about finding that project where the circumstances are suitable for somebody to be a bit brave. And I think designers, developers, fabricators need to, take the chances on those projects to push innovation forward. I think sometimes we all get bogged down in sometimes in the commercial reality of a project. You just kind of need to get it done, do what you know that works. But take the chances to push things forward when they come.
So innovation. Okay. Very interesting. I can see Sergio looking like he wants to say something, so I might ask him about his thoughts on that innovation point.
Yeah, I was thinking, in fact, that the industry needs innovation to progress, because otherwise it will lose ground to other technologies, and the energy sector is very competitive overall. But I was also thinking that innovation will come with challenges. And when we see new technologies being implemented, we also see that the design safety factors and also the fabrication requirements are set to a higher standard compared to proven technologies. And that will be a challenge. If we change to a disruptive technology, it will take time until it gets matured and we can be as efficient as with the proven technologies with these new disruptive technologies. And it applies to bolted connections, of course.
Understood.
But isn't there a way in between, gents? So I do agree with you guys that there is a lot of room still left in scaling up the L flange, but going for T flanges opens up a whole new range of stresses that you can have and loads that you can handle. And I agree, yeah, T flange in the splash zone is not a good idea, so it should be combined with going TP-less. But TP-less with T flanges might be a very conservative solution to bring us years and years of future with flanges.
Michelle, I see you're multitasking. You're also answering questions on the right-hand side there about D over T.
Shouldn't I then?
No, do it. It's great. Have you got any comments around that 160 statement?
I have one comment regarding the D over T, and I was listening to Michel, and I think he's right that with a larger diameter, the D over T is has a trend to grow. But also we shall look at the absolute values, because the D over T is important because you have a relative deformation in your cans. We're handling and we're sitting on rollers, but then you have also the absolute number, so the deflection of the cans. And even if you keep the D over T at the same range, when we go to 12, 13, 14 meters, the deflection is much higher than in an 8 meter, 7 meter monopile. And that brings challenges, even if we don't increase the D over T. And all these have to be, let's say, taken care of from a fabrication point of view. I don't know if you agree, Michel, and on the other
I
people.
agree. I think the problem with D over T is that everybody thinks that if the ratio is 160 or for whatever reason, 160 at 12 meters is completely different than 160 at 8 meters. It's not a ratio that is diameter independent from a fabricator's point of view. However, I think from a designer's point of view, but then I'm looking at my colleague speakers here, you would love to go to 160. However, we shouldn't fall in the pitfall of pursuing something to just squeeze out the last kilo of steel and taking a huge amount of cost, because fabricators are starting to carry around eggs through the factory. And so we are working towards building 11 meters with a D over T of 160. That is our dot on the horizon for the next coming generation of monopiles. But knowingly that it's not all about saving steel when you design, it's actually to design towards cost.
I think it's also worth commenting that the D over T obviously isn't just applicable for fabrication as well. There's all the T&I aspects and the kind of offshore installation where kind of buckling and D over T comes into play. So it's more than a fabrication scope, and I think potentially there might be other drivers on D over T as well for lifting and upending and things like that.
Sure.
Yeah, I was going to make that same point. I mean, we've worked with T&I contractors in the past who've had a pretty firm limit of 130, I believe, from memory, just because they weren't comfortable with the risk associated with hire. So yeah, completely agree with what Nick said.
But for example, in towers, we see now with the new generation of offshore towers, D over T above 250. And that's very light, but it's not necessarily the most efficient. So we have to implement solutions that are expensive ones. And at the end, it's a matter of cost. Are we going to implement this type of solutions in the fabrication of foundations, like temporary elements, rather steel or fixed or hydraulic, or are we going to look for the best efficient production and save, let's say, and compensate the production cost with the steel costs? It's a trade-off we have to figure out in the future, I think.
Very good. Well, Dan Butterworth, I feel like we've responded to your comment in quite a lot of depth, so I hope you appreciate the little sidetrack we've gone down there. We've had a couple of questions in. Phil, I don't know if you want to fish any of those out of the box and see if you think that any of those might be worth asking the panel. Thanks, Dan. That's great.
I mean, we had one there about D over T being very important for pile driving. I think me and Nick have touched on that. That is one of the key considerations. It's not just about the handling. I'm not seeing that many other questions.
I quite like the question at the bottom. Will fabrication facilities be able to scale up faster than, e.g., installation vessels or other parts of the supply chain, or will limitations in fabrication be the hard limit for projects in the future?
That's a good question.
I don't know the answer to
anyone
it.
Anyone feeling like they want to tackle that one? Go on, Michelle. Well done. Go for it.
I think you see people catching up. And when I started to work with SIF, my first seminar, I was coming from a totally different market, although steel oriented. Said, okay, guys, monopiles, 20 meters is finished. And I just started with SIF. So I thought to myself, that's nice, because we will see upwards of 30 meters of water depth. We'll see jackets. Next step was that the anvils of the hammers were too small, and that would be the hard stop. Then the vessel. So it's like this, and it's yes, it might be that we can't keep up at a certain moment, but there is so many new entrants coming to our market as fabricators that I will see that the biggest challenge we have is that we have to grow in volume as a market, as a value chain. We have to grow in size. We have to keep the dimensions and have to keep the tolerances, and even smaller if I listen to the designers. And we have to make a carbon neutral product. So we have to battle all over the place, whilst we have to internationalize. So there is lots of stuff going on, and it's very difficult to say how it works. But it's like creeping up a ladder, and
Yeah.
one year the fabricators will lag behind, and the other year there will be no vessels big enough to install the monopiles. So it's
yeah, really good point. So I think the analogy is absolutely spot on. Can I just change the subject a little bit? TP-less was mentioned a few moments ago. What kind of role do you think that might have to play over the coming years? Does anyone like to take that one?
I'll go in first on that. So I'm quite a fan of the TP-less philosophy. I think there are certain definite benefits that it brings. I think maybe a few years ago it was seen kind of as the poster child or something of solving the woes that we're having with flanges or other kind of connections. And I think maybe now that there've been a few TP-less projects that we've kind of teased out the issues associated with those, it's not quite as miraculous as maybe at first, everyone first thought it was, and that although we've alleviated some issues, with connections and the tolerances there, we've introduced other aspects, the tolerances associated with being able to mate secondary steel offshore or have those connections that work. So I think it's TP-less is definitely one that I'm kind of keeping a close eye on or happy to see advance. But I think it brings its own challenges, certainly for fabrication and other aspects of the design as well.
Is there a fabricator's sort of viewpoint on that one?
I was just going to very quickly add to that, Stuart. One of the other considerations is the ground conditions at the site, because driving damage can become quite quickly governing for something that's TP-less, because of the type of attachments you need to put on the monopile to support the secondary steel later. So I think it has a role to play, definitely. I don't think we'll see a kind of wholesale switch and everyone goes TP-less, but I definitely think it'll have a role to play. Ramble have done a few TP-less projects now. I think maybe we need a few more projects, a bit more data to be able to say, very firmly, this site suits TP-less in the same way that we can quite early on in a project's development in terms of jackets versus monopiles. I think we'll start to get that more and more for TP-less in the future.
I think it for fabrication, or at least from where I'm sitting, it seems to raise a slightly different question, because we speak a lot about diameter, but obviously going TP-less brings length because you're combining monopile and TP. So maybe a question for the fabricators: is length an issue, or do you just have longer yards?
No problem. I think TP-less is a no-brainer, really. And I think the only reason why you shouldn't go TP-less is indeed you have to solve the problem of how to design the attachments for pile driving, and you have installability issues, but that's what is being engineered as we speak. I think driving technologies will become more gentle. Vibration will help a lot. But again, it's technology that's creeping up. But from a distance, TP-less is a no-brainer, because why stick a lot of steel in a TP and not into an MP, because it's just cheaper. So just a matter of time. And at this moment, I fully understand that you don't go TP-less, because with a new turbine and TP-less, you need a big vessel, but these vessels will be there in a couple of years.
From our point of view in ISEA, we don't think that length will be a limitation for fabrication. So as long as you have the long fabrication base to cope with the diameters and in the coating holes, there is no limitation. But of course, there are some specifics about the fabrication of the TP-less monopiles that need to be considered. And I think that the main ones are, first, the coating system, that is a heavier coating system than for standard TP monopiles. You have the aerial and the splash zone coating, normally with polyurethane coating, that you don't have in the standard monopiles. And then you have also the secondary steel supports. And that's something that needs to be considered because it's normally an offline workstation, and it can affect your output. So we see a lot of advantages in going TP-less, provided that the installators can cope with the installation tolerances and things like that. From a cost perspective, we think it's much better than the TP plus MP, but it needs to be accounted also during the planning for the fabrication.
Really interesting. Thank you both for those points there. I think we've given TP-less a good focus today. So let's move on. In terms of those fabrication limitations, what about the raw materials? What about the steel itself? Is that something that you think might be presenting an issue now or in the near future? Michelle, I might start with you.
Not at all. As long as we keep within the range of TMCP processes, which is the clever thing to do as a designer, as long as you keep within the production range of TMCP, I don't see a volume or availability issue at all. So one mill can go to up 120, the other can go to 150, but as long as you stay within those ranges, there shouldn't be a problem, to my opinion.
Very good. Sergio, do you agree?
To be honest, not really. I think in this case, there may be supply constraints. First on the flanges, on the rod flanges, and then on the plates. And on the plates, it's true that there is capacity now in Europe for TMCP plates to 120, but while the foundations are growing and we have to use heavier plates, there is only 1 mill in Europe that can supply plates over 30 tons. And then if we look at the US with import duties for German plates, this will be also a challenge. And there is some new developments we know in the US with a new mill being in construction now, but that's not proven solution yet. So I think there may be some challenges also in the supply of steel.
Okay. And what about these designers who just want to use loads and loads and loads of steel and don't consider the consequences? They're just looking at the price.
Yeah, I mean, I think the price question is an interesting one and how that plays into this because, everyone knows steel's gone up massively recently. It'll be interesting to see if that price kind of sticks or if it comes back down again. And then that material price may then affect the type of choices people make on projects. For example, if the raw material price goes back down, you may see more projects opting for a monopile, which is less efficient, but it's a simpler, easier thing to fabricate compared to a jacket. Whereas if the raw material price stays extremely high or even continues going up as demand for renewables goes up and more countries around the world want to build offshore wind farms, you may see a bigger squeeze on the tonnage, and then that may impact the type of foundations that we see.
I don't know, Phil, if there's a lag between sort of project decisions, design decisions, and then the kind of pricing information you get. So I know kind of on some projects I've been on recently, the kind of decisions have had to have been made because of changes in steel price. And there was, we didn't really have the option to do any design work because those decisions had to be made quickly. So I'm scared that, if there are supply chain issues or price fluctuations, that's going to have to be a risk that's just carried by the owner essentially.
I can see Michel shaking his head. What do you think of that?
Well, I think the way we've modeled it is that if you talk about the comparison between jackets and monopiles, the steel price can triple and still the monopile can outperform the jacket. So steel prices in that respect will not influence the choice of foundations, to my opinion. And also looking at the output, just look at the output of a steel mill. And I'm not talking about the steel mill that we use, but also Wöst or Salzgitter. And look at their output. And let's say the tiny amount that we as offshore wind need. Guys, come on. No problem at all.
Yeah, but at the same time, Michel, when we have cans of 100 tons and you want to make them with plates of 20 tons maximum, I mean, the output of the fabricators will be very low. Unless, of course, we establish a plate joining yard of, 100,000 square meters.
Interesting.
I think it's a good topic, and we have to solve that as fabricators. That's exactly what we're doing at the moment.
So I know we had a full session before on designers versus developers, and without wanting to fully reopen that debate, do we think that the dialogue that goes on between the two designers that I've got here and the two fabricators is as good as it could be, or do you think things could be better?
Shall I
Go on,
jump in on
Nick.
that one?
Yeah, go for it, Nick.
So I think I'm seeing a shift in the amount of dialogue, and I think the kind of discussions on projects is increasing, which is good, because there's definitely a bit of understanding, a gap of understanding between designers and fabricators, and designers certainly don't always know, what is good to fabricate. What decisions should we make? Should we just reduce steel tonnage, or should maybe things are easier for the fabricator if we make alternative design decisions. But I think that's it would be good to get more information up front as well. I think at the moment you kind of have to get engaged in a project before you achieve that dialogue, and often you're in a situation where maybe it's still a kind of a commercial aspect to decision making, and you're discussing maybe with kind of multiple fabricators, and having kind of information that you can base designs on up front would be very useful to have.
Okay, so Michelle, Nick's saying he needs more information. Is it out there? Does it exist?
Well, I think he's got a very, very valid point, because the way that the market is organized, our customers, both the customer of the designer and the customer of the fabricator, needs to get the contracts with ourselves and the designers in place as soon as possible in order to start up their financing, which means that we all book orders on a basic design, and then the door closes and our customers start looking for project financing while we have the order to proceed until they give us the go. And that means that the designer has got a contract that he has won against his competitors with the developer, and just needs to do the job and gets the design certifiable within a certain amount of hours that he calculated. And at that moment, it's difficult for a fabricator to get on board and to have an interface with them, even though say that the supply chain is already decided, so we know that it's going to be a designer A and fabricator B. Still, it's very difficult to get to each other because there's Chinese walls by our customers in between, and so forth and so on. One of the reasons why we go EPC is if we can and try to get the engineering into our scope, because then we work together as one team.
Makes sense.
Yeah.
Bill, any thoughts on that one?
Yeah, I mean, I think, as the guys have said, sometimes you'll have a project where you are able to have that overlap between the design phase and the fabrication, at least early input. That's hugely beneficial. And yet, experienced fabricators will have quite firm and very helpful ideas on the ways that designs can be optimized. And it's not always the lowest tonnage, which is the cheapest overall. Sometimes we may actually add a bit of steel if it simplifies a process and leads to a cheaper end product. I think we as designers won't always have that. I think with experienced European fabricators, they have a long track record. They have very firm ideas about the best way of doing things. I think as the industry expands around the world and we use newer markets, newer fabrication sites, we will more and more have to work with fabricators who it may be their first, second, third project, and they haven't yet built up that knowledge base and have those firm ideas about the best way of doing something. But I think that will then build up over time. It's just a lag to the European ones who've got lots of experience, basically.
I think there's also a challenge for designers in that it's very hard to kind of optimize for essentially kind of multi-parameters. If you're just optimizing for weight, that's easy enough. You have one thing to aim for. But when you start having kind of specific fabricator kind of optimizations that you need to make, it makes sort of your design process a lot more complicated and convoluted. So there's definitely something on the designers there to be able to incorporate these kind of nuances and other parameters into the design process.
Yeah, and that's where you really need a developer, or ideally you have a developer in there who can balance those choices, or at least be involved with those choices, because you may also have a tonnage penalty for enabling a form of installation which is much cheaper overall. And one party on the project can't always make those decisions, so you do kind of need the developer in the middle who can weigh up transportation, installation, design, fabrication, and find out what is optimal.
I think we'd all agree then that earlier collaboration in the project is beneficial from all sides. Yeah. Okay. I'm conscious of time. I'd like to ask one more question, because we just touched on foreign markets there. We all know the industry is growing globally at quite some pace, but at the moment, fabrication is still quite Eurocentric. How do we think that might be resolved over the coming years? Is there going to be more local fabrication? Michelle, what's your kind of views on what's happening right now, and what perhaps maybe needs to change?
Well, as I said, we all, as a value chain, not only the fabricators, but the whole value chain, has to grow in volume. We need more turbines, we need more foundations, more monopiles, more cables, more boats, more what have you. And these things are growing in size. So the tools that we need, the assets that we invest into are for a short moment in time, because if we now invest for a factory that is okay up till 25 megawatt turbines, for sure everybody says, we will never get to 25 megawatts, and 5 years later we're looking at the points of our shoes because we are already at 30. And whilst doing that, the game is becoming an international game. And our customers like us to internationalize because they want to use our experience also in Asian and American markets, for example. That's something we listen to and we work with. But on the basis of that, what we can do in the view of the growth process our company is into. So we're not going to go into an adventure that we can't handle.
Understood. Okay. Sergio, you've been doing some work in South America, is that right?
Yes. Well, I would like to express my opinion here, and I think it's not sustainable to ship the foundations or the towers overseas to the other side of the Atlantic, or even farther away. That's clear. But on the other hand, it's not sustainable to establish a fabrication yard in a place where you don't have a pipeline. So on one side, you can have the unsustainability of the carbon footprint because of the long shipping and things like that. But on the other hand, the business needs to be also sustainable. You cannot just hire 300 people in a country, do one project, and then fire them. That's not sustainable from a social perspective. So we have indeed experience in South America. We have a JV in Argentina, and that has gone quite well because we partner a local fabricator there that was not into the wind industry, but they had the skills for welding, for fitting, and for coating. So that eased a lot the ramp up of the factory, and I think in 1 year it was already profitable. And my opinion is that the manpower and the skills of the people is a factor that is often underestimated. So we see a lot of news about huge investments, hundreds of million factories, but then you have to look for the people that can fabricate the product on time, on cost, and with the quality required by the clients. And that's a challenge, and the human factor plays a key role there.
Interesting. Okay. I'm watching the clock a little bit. Michelle, any final thoughts from you on that topic?
No, here to what Sergio is saying. Exactly on the same spot.
Excellent. Okay. Well, look, we're running a little bit over, so I think we'll probably have to bring this session to a wrap now today. I'd like to thank all of our speakers for taking part. I think it's been a really excellent discussion. I appreciate them being frank and open and honest. And hopefully the audience, you've learned a few things on the way today. I'd like to thank you all for coming along. In terms of tech sessions, we will be back at a slightly different time of Wednesday, the 24th of November at 3 o'clock GMT, where we're going to be talking about emerging markets in offshore wind. And we've got a very special guest to be joining us from the World Bank. So I'm really looking forward to that one. Bit of news from Empire. We will be running our conference, Foundation X, in Bristol in May next year. And we're really hoping it's something we're able to do. And we're looking forward to meeting people face to face after a couple of years of all living behind screens. But so say the dates, 10th of May next year for our conference. But that's it for today. Thank you all. It's been some really good chat down the side. Really, again, thank you to our speakers who've given up their busy diaries to speak to you all today. And that just leaves me to finally say thanks very much. And we will be back on Wednesday, the 24th of November. That's a wrap for today. Thank you very much, everyone. Goodbye.
Thanks, everyone. See ya.